the previous lecture, we have been talking about database management systems and database languages. And in this lecture, we are going to talk about the theoretical background of SQL as far as the relational model is concerned. So SQL is based on an abstract mathematical theory. This is the famous relational model. The relational model was first constructed back in the 1970s at IBM by E.F. Codd, and his relational model provides a theory for the database languages such as SQL. The main idea is that data is stored in tables. So SQL, of course, is a relational database language. Okay, so for example, this is a database table. So this is the basic idea behind the relational model, that we have to use a given table. Of course, you may pose the question that, are there other ways of representing the data? Of course. For example, we can represent the data as a huge graph. These are called the graph databases, such as NoSQL, and these graph-based databases are getting more and more popular with the advent of big data. We are going to talk about it later. What's crucial, that of course we can represent the data with the help of tables, but of course there are other techniques as well. So for example, we have to track the employees of a given company, and of course every single employee has a name, has a gender, has an age parameter, and of course there are several other parameters, but anyways, let's focus on these three parameters. Of course, we have to use some things called the primary key that's going to identify every single employee in the database. So basically every single row is going to be identified by a so-called primary key. By the way, we are going to talk about these concepts on a one-by-one basis. So we need a primary key, a unique integer basically, that's going to identify every row of the database uniquely. So as you can see, Kevin Hart has the ID 1, Joe Smith has the ID 2, then 3, 4, and 5. Okay, so we have the columns and we have the rows in a given database table, and as you can see, there may be unknown values. These are the null values. And what's crucial, that the rows in a table has no specific order. The content of the table is a set of rows basically, and this is exactly why we need the ID. So every single row is going to be identified by a given ID or a primary key, and this is how we can get the given values in a given row. So these rows are not necessarily ordered in ascending order, 1, 2, 3, 4, and so on, because the content of a table is a set of rows. There is a single value associated with a given row and a given column, and this is called the atomic value. So of course, for example, if we are dealing with the gender column, as far as the fourth row is concerned, so where the ID is equals to 4, then as you can see, there is a single atomic value, male. Okay, as we have discussed earlier, unknown values are called null values, and the table must satisfy so-called integrity constraints. So for example, the age parameter should be greater than 0. This is a typical integrity constraint. And by the way, this is the database management system is going to check every time we try to manipulate a data or an atomic value in the database. And of course, every single row has a unique primary key or ID. So this is what we have been talking about, that every single row is identified by a unique integer, the so-called primary key. So we are going to talk about these concepts on a one-by-one basis. I just wanted to point it out, the fundamental basics of the relational model. Okay, and what is the main advantage of the relational model? The main advantage is that redundant data can be stored more efficiently. We can even eliminate redundancy. So every independent piece of information is located in one place, and this is called normalization. So this is the main advantage of the relational model, that we can eliminate redundancy. Okay, so in the next lecture, we are going to talk about how to store the indices of a database efficiently with the help of B-tree data structures. If you are not interested in data structures or the underlying structure of databases, then feel free to skip the next lecture. Thanks for watching.